Good afternoon, students. Am I audible? Okay, so next topic is your computation of critical depth. First, we are going to consider rectangular channel. Okay, so we have considered a rectangular channel. Width of the channel we have considered B. Okay, it's a capital B is your width of the channel. Okay, so capital B we have considered as the width of the channel, and critical depth we have considered YC. Okay, for a discharge Q. Okay, so this is your rectangular channel. The depth of flow we are going to consider as a critical depth, that is your YC, and width of the channel we have considered B, and T is our nothing but your top width. So we all know for rectangular channel your bottom width and top width is same. Okay, your bottom width and top width will be same. Okay, so area for a rectangular channel is nothing but width of the channel multiplied by depth of flow. Okay, so for depth of flow here we have considered critical depth. So that is why B multiplied by YC. Okay. Top width is nothing but your B value. As we know, your top width and bottom width of a rectangular channel is same. Okay. Then another term, this is called Q, small q. Okay. Small q is nothing but your discharge per unit weight. Discharge per unit weight. Per unit weight. Okay. Unit width of the channel. Okay. There is nothing but Q is a discharge divided by B. This is your denoted by small q. Okay. Small q is nothing but your q divided by small b. Sorry, capital B. Okay. Discharge divided by width of the channel. Okay. So now I think we have already derived this equation for critical flow condition, that is your q square t by Ga cube. Q square t divided by Ga cube. So this expression we have already derived. Okay, is equal to 1. Okay, so we are going to consider this equation. So once you consider that critical flow condition, am I audible? Width of the channel. Okay. Divided by G, that acceleration due to gravity, multiplied by area. Okay. Area is nothing but our, we have already discussed this. Area is nothing but, for this case, width of the channel multiplied by YC. Okay. So in place of area, we are going to substitute this. B multiplied by YC. Okay. Then we have cube here, A cube. So it will be B cube multiplied by YC cube is equal to 1. Is equal to 1. Okay. So if you see this B and from here, one B will be cancelled out. So that is why what will be left out is Q square divided by G B square. Okay. And then YC cube. YC cube is equal to 1. Okay. Is equal to 1. So as we are going to find an expression for your critical depth, so what we are going to do, we keep this YC in one hand, or you can say in the left hand side. Okay. And all the other terms we will bring in the right hand side. Okay. So from this equation, you can see YC cube is equal to Q square divided by GB square. Okay. Okay. YC cube is equal to Q square divided by GB square. Okay. So now if you see, we have a term called discharge per unit width, that is small b. Small b is nothing but Q by B. Okay. So here, if you see here, in this equation, we have Q square, we have B square. So Q square divided by B square. So we can directly write here YC cube is equal to small q square divided by G. Okay. Or you can write YC is equal to Q square divided by G to the power 1 by 3. Okay. Q square divided by G to the power 1 by 3. Okay. So you write down the whole steps. Okay. So for critical depth of a rectangular channel, this is the expression. YC is equal to Q square divided by Z to the power 1 by 3. Okay. And you consider this is number equation 1. Okay. So computation of critical depth for a rectangular channel. If anyone asks you to find the critical depth of a rectangular channel, you are going to use this expression. Okay. That is Q square divided by G to the power 1 by 3. That small q is nothing but discharge divided by width of the channel. Okay. Okay. So now, if we consider the specific energy at critical depth or critical condition, see energy EC. Okay. So for specific energy, if you remember, we are going to consider only two terms. One is your pressure head, or you can say Y. In addition to that, we have kinetic energy head, that is your V square by 2G. Okay. So Y, as we are going to consider that specific energy for critical condition, so this depth of flow will be your critical depth plus V square by 2G. V square by 2G. That is your kinetic energy head. Okay, then EC, then we will be having YC plus, in place of V we can write discharge equal to area multiplied by velocity. So in place of velocity we can write Q by A. Okay? And you substitute in place of V. So V square, so it will be Q square divided by twice G A square. Or you can say this is also a critical area, because we are going to consider your critical depth. Okay? So this AC is nothing but critical area. It's similar to the area of a cross section of a rectangular channel. Only the difference is you are going to consider the critical depth. Okay? That is why in the next expression, we replace this Q as we know small q is nothing but Q by B. So Q is equal to small q multiplied by B. Okay? Small q is nothing but discharge per unit width, okay, of the channel. So that discharge you can also write small q multiplied by width of the channel. Okay, so this thing we are going to replace this capital Q. Okay, that is why it's b square by, sorry, b square multiplied by q square, as this is your q square. So that is why this will your b square multiplied by q square divided by, in place of AC we are going to use this expression. In place of area expression we are going to use, so it will be 2g v square multiplied by yc square. Okay? Since q is equal to q by v, q is equal to q into v. Okay, this is the thing. Okay, there if you see in this equation, we have b square here, and here also we have b square, so this will be cancelled out, this will be cancelled out. Okay, so what will be left out, ec is equal to yc plus q square divided by twice g yc square. Okay? Okay. So for yc, we have derived an expression q square by g to the power 1 by 3. Okay, that we have already derived. Okay, for critical depth for a rectangular channel, or you can also write like this: yc cube is equal to q square by g. Okay, that we have already derived just now. Okay, so if you see here, we have q square divided by g. Okay, so this q square divided by g, in place of that we can directly write yc to the power q from this expression, or you can say from 1, you can write from equation number 1, from equation number 1. Okay, okay. So once you put here yc cube, and then you have divided by yc square, so it will be cancelled out and will be left out with This is yc cube and we have yc square. Then this will be cancelled out and we'll be having yc divided by 2. Okay. So if you do the LCM and you will get critical, sorry, specific energy for critical condition is equal to 3 by 2 yc. So you go through the derivation and see if you are have any doubts. Okay, you go through the derivation once again and see if you have any doubts. Then you can ask me, or if you don't have, then we will move on to the numericals. Okay. So remember, this equation is only for rectangular channel. Okay. So for yc value for rectangular channel will be q square divided by g to the power 1 by 3. Okay. And for EC is equal to 3 by 2 YC. This is the relationship between specific energy at critical depth or with the critical depth of flow. That is 3 by 2 YC. Okay. So these are the two equations we are going to use to solve numericals. Okay. So derivation is not in your syllabus, but if you want, you can also derive by same way. Okay. The derivation procedure is same. YC, write down the expression. Okay. Y is q square, because why I have given you this expression. When you go for competitive exam, you have to study for this for other channel section also, like trapezoidal, parabolic. Okay. So at least you write down the expression gz square. Okay. So this is for trapezoidal. Okay. Trapezoidal to the power 1 by 5. Y is q square divided by gz square to the power 1 by 5. Okay. And ec is equal to 5 by 4 yc. See, rectangular channel is very simple to derive also, and is very simple to remember also. So when you go for competitive exam, they used to ask for trapezoidal. Okay. Sometimes they used to ask for rectangular, but maximum time they used to ask for trapezoidal. So that is why you write down this expression. For yc, it's twice q square divided by gz square. Z, I think you all know. Okay. When you talk about trapezoidal, we will be having side slope, that is 1 is to z. Okay. So that z is this. Okay. 2 q square divided by gz square whole to the power 1 by 5. Okay. and EC is equal to 5 by 4 YC. Then you write for parabolic section, YC is equal to 27 Q square divided by 8 GK square to the power 1 by 4 for parabolic section. Okay, and EC is 4 by 3 YC. EC is equal to 4 by 3 YC. Okay, so these things for trapezoidal and parabolic. Okay, you just write down the expression. Okay, so for rectangular it's 3 by 2 YC. EC is equal to 3 by 2 YC. For trapezoidal is 5 by 4 YC, and for parabolic is 4 by 3 YC. So we are going to end this meeting here, and after 5 minutes we are going to join again, and then we are going to solve numericals related to your specific energy. Okay. Of 4 meter wide, the width of the channel is given for. Kindly write. So we are going to solve the first numerical related to our specific energy. This is our first numerical. Kindly write down the numerical. Okay, a rectangular channel of 4 meter wide. The width of the channel is given 4 meter. Carries a discharge of 15 meter cube per second. 15. Okay, it's 15 meter cube per second. Discharge, and has a specific energy of 2.5 meter of water. Specific energy is given 2.5 meter of water. Determine the alternate depth. Determine the alternate depth and corresponding Froude number. for this flow. Okay, determine the alternate depth and corresponding Froude number for this flow, and also find the critical depth and a critical slope YC if the Manning's n is given 0.02. Okay, so you write down the first the numeric, then we will move on to the solution. Okay, and also find the critical depth and the critical slope if Manning's n is equal to 0.02. So this is the numerical. So before solving this numerical, if you remember that specific energy curve, okay, so this is at an angle of 45 degree. It's E is equal to Y. Okay. In x-axis we have energy, that is your specific energy, and y-axis is equal to depth of flow. Okay. Then for any particular discharge, if you draw a specific energy curve, it will be in this form. Okay, for a particular discharge. Okay. So for any energy apart from your YC, so this is your critical depth. Sorry, this is your critical energy. I can say E minimum, specific energy minimum for that particular discharge. Okay, and corresponding to that particular E minimum, the depth is called YC. Okay. Apart from this, if you consider any value of energy, that is here is given 2 meter, 2.5 meter. So if we consider the 2.5 meter energy, draw a line, it will intersect the whole curve into 2 points. One is here, here. So for that particular energy, you'll be having two depth of flow. Okay. For that particular energy, you'll be having two depth of flow. Okay. So these two depths are called alternate depth. One you consider y1, another one you consider y2. So both the depth, your specific energy is same. So this is called your alternate depth. Okay. So we need to determine these two alternate depth. Okay. That y1 and y2 we need to calculate. Okay. So what is given? The discharge is given is 15 meter cube per second. Okay. And our specific energy is given 2.5 meter of water. For this particular specific energy, we need to find out the alternate depth. What are the two depths for which your specific energy is same? Okay. Then width of the channel, or they have said that the channel is a rectangular channel. Width of the channel is given, that is 4 meter. Okay. So this is your first part of the question. You need to find out this y1 and y2, and at the same time, if you remember the Froude number, we have already discussed. Okay, Froude number is dy root over gd. Okay, or for rectangular channel, you can directly write vy root over gy. Okay, so that thing we have already discussed. Okay, so for each depth, what will be the Froude number? For y1, what will be the Froude number? For y2, what will be the Froude number? We need to calculate. Okay, first we need to find out the y1 and y2, and if you remember, if this is your critical point or minimum energy, and then if you draw a line, it divides into two half. One is in supercritical and one is subcritical. Okay, so this supercritical, the Froude number is greater than 1. So these things we have already discussed. Okay. And for subcritical, your fraud number is less than 1. Okay. And for critical flow, your fraud number is equal to 1. For YC, your fraud number is equal to 1. Okay. So now what we have to do, we have to find out this Y1 and Y2 value for which your energy is same. Then we need to find out the fraud number for both the depth. Okay. And see, your Y1 will be in supercritical and Y2 will be in subcritical. Okay. So definitely when you find out the fraud number for supercritical, that means for Y1 value, that should be greater than 1. Okay. And for subcritical, that Y fraud number for Y2 value should be less than 1. Okay. Okay. So this depth of flow 4 meter is given, discharge is given, specific energy is also given. Y1 we need to calculate, Y2 also we need to calculate. Then we have critical depth. That is the second part of the question. Okay. So this also we are going to discuss. First we are going to find out the Y1 and Y2 value, and then we are going to find out the fraud number for each depth. Okay. So first we consider this specific energy equation. Okay. So we all know specific energy. We will consider only two terms. One is your depth of flow, and the one is your V square by 2G. Okay, kinetic energy head, V square by 2G. The specific energy is already given, that is 2.5. Okay. This is Y plus, for V square we can replace V by V is equal to Q by A. Okay. So it will be Q square divided by twice G A square. Value is given, 2 into G is nothing but 9.81 multiplied by width of the channel. I think it's 4 meter, 4 square, because area is B into Y. Okay. Area is B into Y. Okay. You can see this equation. This is 2.5 plus Y plus 15 square divided by twice G multiplied by area. Area is B into Y. B value is given 4 multiplied by Y whole square. Okay. So definitely you have one equation. If you see this equation, you have only one unknown. That is your Y value. Okay. So you just try to solve. It depends on you how you are going to solve this equation. There are various methods, or you can directly use your calculator also to solve this equation. Okay. So if you break again, you can take LCM. That is 4 square is 32, and then 15 you can again 225. Okay. 16 to the 32. Okay. Okay. Then again you do the LCM and then you cross multiply, and we will come up with a quadratic equation. Okay. You see, you will get a quadratic equation. Okay. So for solve that quadratic equation and find out the Y value. Okay. You can use your calculator also. One is your 0.62 and one is your 2.37. You find out this 5 meter of water, you'll be getting two value, two y value. Okay? One is y1 and one is y2. Okay? And then we will be having another depth, that is our called critical depth for E minimum. Okay? Or you can find out the YC value. We have already discussed for YC that Q square by G to the power 1 by 3 for rectangular channel. Okay, you can directly use this equation, find out the YC value. If that Y value is less than YC, then we can say it's in supercritical. If that Y value is greater than YC, then you can say that depth is in subcritical flow. Okay, so once you find out this two depth, you can find out the Froude number. Okay, so from here we can say this is in subcritical and this is in supercritical. Okay, so for subcritical, your Froude number, when your depth of flow is more, your Froude number will be less. Okay, when your depth of flow is less, your Froude number will be more. Fr is greater than 1 for supercritical. Okay, and for critical depth, your Fr is equal to 1. For critical depth, your Fr is equal to 1. Okay, Froude number. So our first objective is completed to find out the alternate depth. Okay, alternate depth are the depths for which your specific energy is same. Okay, so now we have to find out the Froude number for each depth. Okay, so we know that Froude number equation is nothing but Vy root over Gd. Okay, D is nothing but A by top width. Okay, so for as we are considering rectangular channel, for area is B into Y, and for top width of a rectangular channel, we can directly write B. Okay, so this will be cancelled out, Y is equal to Y. Okay, so in place of D for a rectangular channel, we can directly substitute Y. Okay, so this will be Vy over Gy. Okay, so now if we want to find out the Froude number for your subcritical flow, so in place of this Y, we are going to substitute 2.37. Okay, and velocity, we don't have velocity, so in place of velocity we write Q by area. This is given 15, area again B multiplied by Y. That Y will be again this 2.37 if we are going to find out the Froude number for this depth. Okay, this Y value is nothing but 2.37. So likewise you can find out the Froude number. Okay, so this is this Froude number will be in subcritical, so definitely it should be less than 1. Okay, so you see, first you find out the Froude number and you check it is less than 1 or not. Okay, so try to calculate the Froude number. And the Froude number for this particular depth, you are going to get 0.33, which is less than 1. Okay, so you check and see if you are getting the same value or not. So from the Froude number also the flow, this is for depth of flow less than YC. Okay, and this is for depth of flow greater than YC. Okay, so this is in critical flow, this is your supercritical. In 6-1, you try to find out for the next depth also. For depth of flow 0.62, you will get around 2.45. Okay, 2.45. Yes, yes, correct. Okay. So definitely it's greater than 1. So you can say this flow is in subcritical. Sorry, it is in supercritical. Sorry, greater than 1. So it is in super. When there is a supercritical, your depth of flow is less than less than critical flow. And when your depth of flow is less, then your Froude number is more or increase. Is equal to, as we are discussing about rectangular channel, q square by g to the power 1 by 3. Okay, to the power 1 by 3. Okay, so q is not given, so in place of q you can write discharge divided by width of the channel. Okay, so n value is already given. Okay, a slope we need to determine. Velocity we can write q by a in place of velocity. Okay, 1 by n r to the power 2 by 3 and sc to the power half. So we need to find out the critical slope. Okay, so if you simplify, you will get this expression. You will get this expression. Sc is equal to is v multiplied by n, small n, that is the roughness coefficient, divided by r to the power 2 by 3 whole square. Okay, because you can directly find out discharge by area. Okay, discharge is 15. Okay, and yc value is already we have calculated, so you can directly find out the velocity from here. Substitute here, n value is given, r is again a by p. Okay, area we have already calculated, that is b multiplied by yc, and for weighted perimeter it will be twice yc plus b. Okay, so yc we have already calculated, multiplied by 2 plus b is given 4 meter. You will get the weighted perimeter. Then you substitute here area and weighted perimeter, find out the r value, substitute here, and you can directly find out the yc value. See, you are getting the same value or not. Specific energy. Only you need to understand this graph. We will continue in the next class. Okay, thank you all.
Sir, what about written is?
Yes, pardon.
Sir, what about written is?
Or you can give in the chat box. Okay.
Okay, sir. Thank you.